Every day, developers are building AI-powered applications using large language models. Chatbots, AI coding assistants, document analyzers, customer support agents, and autonomous workflows are all powered by the same underlying technology. But here's the surprising part. Building your first LLM application is much easier than most people think. In this video, I'll show you how to build a working AI application from scratch, explain every component involved, and help you understand the architecture behind modern AI apps. Traditional applications follow fixed rules. A user interacts with a front-end. The front-end calls a back-end. The back-end reads and writes to a database. The app responds with behavior that was explicitly coded ahead of time. LLM applications introduce intelligence by allowing a language model to reason, summarize, classify, extract information, write content, and answer questions. That means the application is no longer limited to a fixed set of rules. It can interpret natural language and produce useful responses based on the user's request. Common examples include AI chatbots, document summarizers, customer support agents, code assistants, and research assistants. Today we'll build the simplest possible version, an AI assistant. Every LLM application has four main pieces. First, the user interface. This is where users type prompts and read responses. Second, the backend. The backend processes requests securely and protects secrets like API keys. Third, the LLM API. This could be GPT, Claude, Gemini, or an open-source model served through an inference provider. Fourth, the response layer. This displays the model's generated output in a way the user can understand and act on. Once you understand these components, you can build almost any AI product. We'll use Python because it's beginner-friendly and widely used in AI development. Start by creating a new folder called First LLM App. Then move into that folder. Create a virtual environment so your project dependencies stay isolated. Then install the OpenAI Python package. Your project can be very small at first: an app.py file, an environment file, and a requirements.txt file. Next, create an API key from your LLM provider and store it securely in an environment variable. The important rule is simple: never hardcode API keys in your source code. API keys are credentials. Treat them like passwords. Now let's make the first LLM API call. In app.py, import the client library, create a client, send a prompt to the model, and print the output. The input can be something simple, like, explain Kubernetes in simple terms. That's it. You just built your first LLM application. The application sends a prompt to the model and receives a generated response. Under the hood, your code is making an API request, the model is generating text, and the response is returned back to your program. At this stage, the prompt is hard-coded. That works for a first test, but real applications need user input. So the next step is making it interactive. Replace the hard-coded prompt with a question from the terminal. Ask the user, "Ask me anything." Then send that question to the model and print the response. Now users can interact with the model directly. Try asking, "What is a vector database?" The assistant should respond with an explanation in plain language. Congratulations! You now have a functional AI assistant. But most AI applications don't send user prompts directly. Instead, they include instructions. This is called a system prompt. A system prompt defines the behavior of your AI. For example, you might tell the model, "You are a senior software architect. Explain concepts clearly. Use examples." That instruction changes how the assistant responds, even when the user asks the same question. This is how one LLM can become many different products: a coding assistant, a travel planner, a marketing expert, or a customer support agent. The model is general. Your instructions shape the experience. Next, let's talk about memory. Models don't automatically remember previous conversations. Your application must provide conversation history. Without memory, a user might say, "My name is John." Then later ask, "What's my name?" If the earlier message is not included, the model may not know. With memory, your app sends the conversation history along with the latest question. Now the model can answer, "Your name is John." This simple idea powers chatbots and AI assistants. Memory is not magic. It is context management. Your app decides what previous messages to include, how much history to keep, and when to summarize old conversations. Now let's move to retrieval augmented generation, usually called RAG. What if your AI needs access to private company data? A general model may know public information, but it does not automatically know your internal docs, PDFs, customer records, policies, or project notes. That's where RAG comes in. The idea is to store your documents, search for the most relevant pieces when a user asks a question, and send those pieces to the model as context. The model can then answer using both its language ability and your private knowledge. Examples include internal knowledge bases, PDF question answering, documentation assistance, and customer data support tools. Most production AI applications today use RAG because it gives the model access to the right information at the right time. The next evolution is AI agents. A basic LLM app receives a prompt and returns a response. An AI agent can reason, choose tools, search the web, query databases, send emails, execute code, create reports, and then return a final answer. Agents are becoming the foundation of next-generation AI applications because they connect language models to action. But before you build agents, make sure you understand the basic application loop: prompt, context, model, response, validation. Finally, let's cover common beginner mistakes. Mistake 1: hard-coding API keys. Mistake 2: sending entire documents to the model when retrieval would be cheaper and more accurate. Mistake 3: ignoring token costs. Mistake 4: having no error handling. Mistake 5: writing weak prompts and expecting reliable behavior. Mistake 6: skipping user validation. Avoiding these mistakes will save you time, money, and frustration as your applications grow. Let's recap the full architecture. A user interacts with the front end. The front end calls the back end. The back end applies prompt engineering and may retrieve relevant knowledge through RAG. Then it calls the LLM. The response comes back and is displayed to the user. You've just learned the foundation of modern AI applications. You now understand how to call an LLM, create an assistant, add memory, connect external knowledge, and evolve toward AI agents. The best way to learn from here is simple: build something. A chatbot, a coding assistant, a document analyzer, a research agent. Because every advanced AI system starts with the same first step. If this video helped you, hit like and subscribe. And in the comments, tell me what AI application you're planning to build next.